Hello YouTube learners, students, friends. This is your friend Dr. Satish Singhal PhD, Professor of Computer Science at Communal College, Torrance, California. In this video I'm going to talk about input and output in C++. Uh, I have a entire chapter on it separate, but in order to do labs we need to learn about input output rather quickly. So this is some extraction of information from later chapters which I put together in a PowerPoint and in a video. So let's go ahead. And what I want to say up front is that I'm only going to talk about input from standard input and standard output. So what are those things? When you input data from a keyboard or from a ASCII file, which means file has only characters, no fonts, no bold, nothing, just ASCII. Each character has the ASCII value of certain type. That is called standard input. And standard output is when you're outputting information to the screen, display screen, or to a ASCII file where data are just written as ASCII characters, not having any italic, bold, or font variations. So really the topic here should be standard input and output in C++, not input and output in C++. This will become more clarified as we go deeper. Okay, basics of input and output, typically called I/O. Chapter 5 of my ebook gives all the details. We'll give necessary information here to be able to do input from keyboard and output to console. So that's pretty much the focus of this video. You should think of input as a stream of data in form of characters that flow from your keyboard to the RAM of your program. In the RAM there will be some variable setting into which your keyboard will be populating the data. This is what happens when input into program variables is done. So think of input as stream of characters flowing from keyboard into the variable in the RAM. Only variable. Constants are not inputted from keyboard in C++. They have to be hard-coded. Alright, so just remember that. Constants are not, you cannot populate constants in C++. There are other languages where you can do that from your keyboard input. They are always hard-coded. Okay, same way you can think of outputted data as a stream of characters flowing from RAM of your program to your monitor display system or to the file that is ASCII file. Now outputted data is not limited to variables only. That could be a constant being outputted or a named constant being outputted. Okay, so output does not have that limitation that input has. So one more time, let me just explain, let me just emphasize. Input in C++ can only and only be done from the keyboard or the file into variables only. Constants in C++ are always hard-coded in the program. Using character streams for I/O is also called standard input and output, and we illustrate this in the next slide. Excuse me. So you can think of this type of situation. Here's RAM or memory. So what kind of data communication takes place? When you are prompted to input data from the keyboard, user will say, okay, input such and such data. And the variable for containing that data already has been created in the RAM, declared and created. So your keyboard will you'll just type, and that will be entered into that variable. Then CPU will run your program. It will use that variable and other variables, of course, do some computation, execute some algorithm, and once an output variable has been created or populated, that would be character by character. Actually, it doesn't happen character by character. There is a buffer into which that is placed, and then that entire buffer is printed onto the monitor. So keyboard and monitor are usually the standard input and standard output device, but data files can also be, ASCII data files can also be considered a standard input and standard output device. So that's how the data communication takes place. So pause the video here, look at this picture more carefully, and hope you understand this rather well. Which include is required for IO? The required preprocessor include for IO is I/O is number include IO stream. The IO stream is located in the STD namespace. Thus, we also add the line using namespace STD, which is a separate line terminated in semicolon. There's no semicolon required in the include lines because those are not program statements. Those are preprocessors. If you put that here, it's just going to give you some sort of warning. Namespace concept is discussed in Singhali book chapter 3, so look it up there. Notice when file standard IO is done, an additional include is required. That is called number include F stream, and we'll talk about that a little bit later when we get ready to do input and output from the file. And usual rule of having includes before main function is followed. So this will be like pretty much like the first line of the program. First program line basically, and there might be other includes, of course. Okay, so we do include input through a variable, keyboard input through a variable called cin, and we'll talk a lot about cin very soon. So what is cin? This is used for data input from keyboard, and cin is defined globally in namespace std. What that means is anything before main that got defined as a variable is called a global variable, and it's defined globally in namespace std. So cin is a variable of type iStream, which is a class in std namespace. Okay, since this is kind of complicated, I will simplify that for you. You can think of cin as a software app that helps data input from keyboard. So think of that as a little piece of software. What is the meaning of global variable? Meaning is that once you have done number include IO stream, the source code of that file is added to your program, and that allows accessibility to cin object declared in that file. It becomes globally present and available to your program inside main. So as long as it's somewhere before that, it becomes available to you. Okay. Okay, cin works with something called extraction operator. So we are extracting data from the keyboard, putting that into a variable in the RAM. That's why this operator, which has two, what do you call it, greater than sign, and two symbol form this operator, not one. That is used in conjunction with cin for data input from the keyboard. So cin, in order to work, also need extraction operator, and operator is built of two symbols to its right, and the variable you wish to populate will be further right to operator arrow arrow. I just call it arrow arrow, okay? or actually I should call it extraction operator. So let's just call it extraction operator. Operators that comprise of two characters in C++ can never have a blank space between them. That's a C++ rule. There are some operators which are single character, but then there are operators which consist of two characters. When they contain two characters, there's no white space between them. They must be contiguous. So while extraction operator written without any space between two greater than sign, this is correct. But if you type it this way, one greater than sign, and then you leave a whole bunch of space and another one, that's a compile error, because you're violating the rule that in a two character operator in C++, characters cannot have white space in between. That's a C++ rule. Okay. Extraction operator, which is these two symbols, is actually a shorthand for an input function in iStream class, which can also be written like this: operator greater than, and then in var. When you do that, that can also work. And in var is a variable into which input is desired. I don't want to beat this onto your head, but let me say one more time. This can never be a constant of any kind. This always must be a pre-declared variable. Okay? But we don't need to use the word operator. What works is cin extraction operator in var. So that works fine actually. Okay? Use of parentheses is optional. It kind of looked nice, so I put them in, but you don't have to have. In var is a variable declared before input line and is populated with the user data in above line if they type the data and press enter key. One more time. This cannot be a constant. This has to be a pre-declared variable. You never do input into a constant of any kind. One more characteristic of extraction operator is that its arrows are always going into the variable in which input is being done. So think of this as a source arrowing into a destination. A lot of people confuse and make the opposite one less than symbol. That would be a compile error. But if you think of scene as a source, variable as a destination, and then correct form of arrow would be arrows entering into the variable. Okay. Let's talk more about extraction operator, which is these two greater than sign. In the syntax cin extraction operator and then the variable in var, parentheses are optional, it may be interpreted as follows: that extraction operator is a binary operator. When we say binary operator in programming languages, that means it must have two operands, one to its left, one to its right. And the one operand is on the left and the other is on the right, and you cannot be missing either one of them. Binary operator requires, like in multiplication, which we have mentioned in IOAA technology video, if you have asterisk, why, it's a binary operator. It must have one on the left and one number to be multiplied on the left, another multiplied to the right. Same applies here. But there is a little bit of a difference. There is a directionality, and we'll discuss that very soon. Left hand of extraction operator must always be cin. It can be anything else. Or it could be a file handle when we talk about input from the file. But from the keyboard, when we are doing input from the keyboard, the left operand of extraction operator must always be cin, and right operand must always be a variable that has been already declared before input line, and the variable is in scope. That means it's visible at the line for input. And when we do input from the keyboard, it is important for the user to have enough clarity and direction that variable invar data type must match the data type being inputted. And there are exceptions with that, but that's otherwise we have input mismatch problem, and I discussed that also in chapter 5 in a lot of detail. So this is the summary of standard input from the keyboard. Figure below gives high level summary of standard input from the keyboard. You have the RAM cloud, you have a variable called invar sitting there. Scene is a piece of software that is available to us, and somewhere from the keyboard we are going to type the data. Scene will just grab it. Scene and extraction operator will grab it and put that into this variable called invar, which is sitting in the RAM cloud. So scene and its function operator, extraction operator, get data from the keyboard and push into the variable invar. So you can kind of make a mental picture of this, and one more picture we showed earlier of data input from the keyboard. Okay, so let's use some examples of variable declaration, user prompt, and use of cin. Okay, so let's say we wanted to enter data for the number of students in the class. Well, first we need to define a variable. That will be our line 1, int num students. So this becomes the memory holder in the RAM into which data will be stored. Then we do a prompt. Prompt is done by cout, which we'll talk very soon. Enter number of students in the class must be whole number because we have defined num students to be a whole number type. Remember my video on data types. So that'll be my line 2, and then I do cin extraction operator num students. Okay, so when user enters in response to this line some number 10, 15, 20, whatever, and press the enter key, then cin will grab cin and extraction operator will grab that number from the keyboard and put into num students. Okay, this is very important to understand. That sequence in which line 1, 2, and 3 are coded is inflexible. Sort of. You can declare int num student after the prompt if you like. Usually bad idea. But when this input is done, this must have been already defined. If it's not defined, where is cin going to enter? That means it must have been created in the RAM. You can do prompt after that or before that, it doesn't really matter. So my saying that the 1, 2, 3 is inflexible, well, it's not exactly. You could define int num student after that too if you like, but this makes more sense to me. They don't have to be contiguous, you could do other things in between, but it's a good idea that line 1 is the first line, line 2 is the second line, prompt is the second line, and input is the third line. Although you can switch 1 and 2 around if you like. This makes it in scope. Read chapter 3 for definition of scope. Let's see more example of use of cin. Input data. Enter of GPA of a student, double GPA. After this line, GPA memory location is available in the RAM. Prompt the user enter current GPA. This dialog displays on monitor, and we say cin extraction operator GPA. After this line, GPA memory location is populated with user entry. So just remember, these two greater than sign are called extraction operator. remember the direction of extraction operator. It always goes towards the variable that is being populated. Okay. If you reverse the direction, that's no longer extraction operator. Okay. Extraction operator strictly is these two characters right next to each other. That's the entry of last name. I define a variable last name. This creates a blank memory in the RAM. Then I prompt enter your last name hyphenated or one word, not white space. And then I say cin extraction operator last name. Whatever last name user enters and press enter key is populated into last name field variable. Okay, that's the example of using of cin. One more time, we are just gonna define this, kind of beat you on the head with this reality, directionality and non-commutative nature of input expression. So what was input expression? This entire thing here is an input expression. And this expression is directional and non-commutative. The extraction operator extracts the datum in the input stream and populates the right operand variable with that datum. Extraction operator is directional. You cannot change the direction of its arrows. The whole assembly below has an inflexible order, cin extraction operator, in var, use of parentheses optional. This whole expression is non-commutative. That means you cannot change order of tokens in the expression, cin extraction operator and in var, in above expression. Okay, so this expression is non-commutative. And for the reason of that, all these are compile errors. Okay, this is compile error because arrows going in the other direction is no longer extraction operator. That's an insertion operator that is used with cout. This is not extraction operator. So you have to be very careful with that. This is compile error because cin can only be the left operand and in var can only be the right operand. You cannot switch the order. This is wrong because first the order is not right, and then you're no longer using extraction operator, you're using the insertion operator. Okay, and this is wrong because one of the operand is missing. The rule in C++ is for binary operator to function, both operands must be there. Okay, there are a lot of rules I'm saying here in which if you like you can write them down, and I'm saying that in words. Okay, last one is compiler because right operand is missing. So this is not extraction operator. This is not extraction operator. Here switching of cin from left to right is not allowed, and missing an operand is not allowed. This slide is very important. You should really pause video here and make sure you look at it very carefully and understand and write down any questions you have. Now we talk about output to a display or a monitor. Such output is called standard output also because a stream of characters is taken from the RAM and displayed on the monitor. I showed that in one of the previous slides. That data stream is going from RAM to the display or monitor. Output to monitor is done using cout and this less than symbol, no space. This is called insertion operator because data is being inserted into an output stream which is eventually outputted on the display or the console. So when you have two less than sign, that's called a extraction operator. Okay, so extraction operator points to the cout, its left operand. Insertion operator points to its right operand. If you can just remember that, you're not going to have any problem. Okay, so let me say those words. Extraction operator points to right operand. Insertion operator points to left operand. Left operand. Okay, and then we're going to put more here. In above expression, cout is an object variable of class OStream. And this symbol here, noise space, is called insertion operator, named so because it inserts data into the output stream. There is one difference, as I mentioned that difference before, compared to cin, however. While right operand to extraction operator in input must always be only a mutable memory location, that means it's a variable. Right operand to insertion operator can be any of the below. It could be named constant, it could be a literal constant, soon we'll show example of that, or a populated variable. So this is more flexible in that sense. Extraction operator is more strict. Its right operand can only be a variable. So these are the example of output using cout and insertion operator. I want to output a literal string, let's say hello world. Then I have cout, insertion operator. In double quotes I have this string hello world / n means go to the next line after this output. So whole string is enclosed in pair of double quotes. I could output a literal int that is typed into the source code, cout 5, and it'll output 5 to the console. I could output a literal double like GPA of some type, and I'll say cout insertion operator 3.4, or I could output a literal character, and I'll say cout insertion operator quote p quote closed. This will print p, this will print 5, this will print hello world, this will print 3.4. Or sorry, I have a populated variable in var that was already populated by cin and might have gotten modified by doing some processing, and then output any memory location in var is a memory location, and then I say cout insertion operator in var. So these are some of the examples. Once again, insertion operator is a binary operator. It must have cout as a left operand, and right operand could be a constant, 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 or a variable. Could be any of those. Okay. And that's the same issue here. Directionality and non-commutative nature of insertion operator. This one. The insertion operator takes data in the output stream and displays it on the monitor. Just like extraction operator, the insertion operator is also directional, and you cannot change direction of its arrow. In fact, it's no longer insertion operator if you wrote it like this. Okay. Whole assembly below has an inflexible order. I say cout in var, which is a populated variable, or I say cout hello world, which is a literal string. It's inflexible order and it's non-commutative, means you cannot change the order of tokens, and tokens are cout, insertion operator, and in var. This order is inflexible, and that's why all these are compile error. And one more time I'll explain. If I say cout in var, parenthesis optional, Well, look here. This is not extraction operator. This is insertion operator. Extraction operator, this one always points to its left operand. Insertion operator points to its right operand. So this is not even an insertion operator that we need. This is extraction operator. This doesn't work with cout. Same problem here. I do have insertion operator, but the rule is that left operand has to be cout and right operand has to be in var. Okay, what did I do here? Okay, these two are same, so ignore one of those. I might have meant something else here. Yeah. And then if I do cout insertion operator, well, that's wrong too. Binary operators never work without both operands, left and right. So I left out the right operand, and that's the mistake here actually. Okay, this slide again is very important so that you can avoid all the confusion when you. So insertion operator is only this type. This only works if cout is the left operand, and you must have something to be outputting as the right operand. So here's the high-level summary. There's a variable which is already populated. So what cout does, it takes that variable, and cout software that connects to the monitor will go ahead and output it to the monitor. It won't output as in var, but it will actually output its value. So cout and its function operator, insertion operator, gets the data from RAM and push it on the variable. Generally, it fills a buffer first. So try to see that you picturize functioning of cout and insertion operator using this picture. Last thing I want to talk about is cascaded input and output. For the purpose of clarity in programs, when doing input from the keyboard, cascaded input is not allowed in CS1. Points will be taken off if cascaded input is done from the keyboard in CS1, this class. But cascaded input from data files is allowed. So right now, we will not discuss cascaded input any further. Okay. Cascaded output means that one use of cout can output many tokens as long as they are separated by insertion operator less than sign. Okay. And we show its use in next slide, where we use values stored and populated variables and little constants for cascaded output. So this is here's the program. Let's take a look at it. I have an age variable. I put 22 in there. I have GPA variable. I put 3.95 there. I have somebody's name, string John Doe. I put John Doe in there. And I declare two bool variables. Test type 1 is true and test type 2 is false. So now I can take all these variables, output them, plus add some literal constants of my own if I want. So I say cout insertion operator name. Well, name stores John Doe. So first output right after from the first token will be John Doe, like this. Then I have a literal string here, is a CS student, and then it says, okay, next output should be on the next line. So this gets outputted literally with a line break. That means next output will be on the next line. So is a CS student gets outputted as it is. Okay. But since I have /n here, that means do the next input on the next line. And next input is also a literal string. It says he is, so he is gets outputted as it is. The next token is age. Well, age was 22. So computer takes 22 from here and outputs that there. Then I have a literal string again, years old slash n. That means I print years old in a dot, and next output will be on the next line. And that's what exactly happens. Then I have another literal string, his GPA equals, and double quotes. So his GPA equals gets printed as it is. And then I have GPA variable, which has 3.95 in there. And when I output, it grabs the 3.95 value and outputs there. And there is a slash n, means next output should be on the next line. And then I have a literal string again, and he does very well in, so that gets outputted as it is, and he does very well in, and slash n means do the next output on the next line. And then I have two boolean here, two bulls. Test type 1 stores true, he does very well in true. Test 2 type, and there is a space in between, so I put a space. Test type 2 was storing false and just prints false, and then literal string tests. Okay, this example of cascaded output is very good actually. It saves a lot of typing of cout again and again and again. So please pay a lot of attention to this. This is also in my PowerPoint, whose copy my class will get. Those who are watching the video can pause the video here, analyze the way my words have analyzed it, and you will understand the cascaded output, which is very useful in outputting data. More on cascaded output. Example on previous slide shows the syntax of cascaded output. It is simply that you have cout, insertion operator, first token, insertion operator, second token, insertion operator, third token, and you can go as many lines as you like. Each token must be separated by the insertion operator. Okay. Each token is one of the below: populated variable, literal constant, named constant. You cannot output a non-populated variable. That's garbage in, garbage out. Constants are always populated. C++ will not allow you to use a non-populated constant. Literal and named constants are discussed in chapter 3 of Singhal book. So what you should do, let me go back. Type this code in the main function. Do not copy and paste, because codes will not come out right, and then you're going to get frustrated. Actually, declare a main function, type this code, and then confirm that this is coming out correctly. And you can change the values here, age, GPA, and name. Leave these as it is, and then you will see you will have a different output in the program. So basically, type and run this one for your own actually. All right, do not copy and paste, it will not compile. So that's my lecture on input and output. At this time you will learn about this more in chapter 5, where I'm not giving any videos in that chapter. You kind of read the chapter and learn yourself. There's a lot of good stuff in that too, especially input mismatch. But for now, to do a couple of labs, this is all we need. Once again, this is your friend, Dr. Satish Singhal, PhD, Computer Science, El Camino College, Torrance, California. Thank you.